All right, today we're going to be talking about fear, which I hope these images don't inspire too much. As an outline, we're going to look at fear as a tool that helps us to solve problems of survival, right? Fear is a tool that helps us to stay alive. And we're going to be looking at a specific issue, and that's whether there is a preparedness to acquire some fears. So whether humans and other animals have predispositions to acquire certain fears with minimal input from the environment, or whether humans and other animals acquire all fears with equal ease. So we're going to begin by looking at some animal research, and then we're going to end with a discussion of whether humans have a fear module, a specific part of their brain dedicated to the acquisition and processing of certain fear information. But first, I want to distinguish between fears and phobias, because one is more adaptive than the other. Right? Fears are unpleasant feelings that arise as a normal response to a realistic danger. So, for example, if you're walking through the woods and all of a sudden you walk into a bear that's 20 feet away from you, chances are you'll experience fear, and you feel something unpleasant, and it's also a natural, normal reaction because the bear obviously, you should have some distance with the bear, right? They're potentially very dangerous. So fears are adaptive in this sense, right? Phobias, on the other hand, are fears that are wildly out of proportion to the realistic danger, right? So that's why they're often described as irrational fears. And so you might have a fear of bears, which is reasonable, right? You shouldn't be indifferent as to whether or not there's a grizzly bear in the room with you. But a phobia is clearly maladaptive and irrational. So if you can't even look at a picture of a bear, for example, that would be unrealistic, right? Because the picture is obviously not dangerous. So we're going to begin then by looking at why people and other animals have the emotion of fear. So what does it allow us to do? So is it an adaptation? And then how specific is the adaptation? Well, in order to look at whether fear is an adaptation, a good place to begin is by looking at the things that fear makes you do, right? And Marx has done some early research on this. He looked at adaptive responses that are produced by fear, right? And once you go through these, you can see why they would be adaptive, right? So the first thing, or one of the first things that fear can make you do is to freeze or become immobile. Right, so as I said, if you're walking through the forest and all of a sudden you run into a bear, chances are you're not going to keep walking in that direction. Chances are you're going to freeze, right? You're going to stop moving. And why would you do that? Why would your body make you stop like that? Well, the first thing is that it prevents you from moving closer to the danger, right? But also by freezing, it helps to minimize or lessen anyway the chance that you'll be noticed by the predator, right? Some predators only respond to movement and they don't detect stationary objects very well. The second thing that fear makes you do, which is also adaptive, is it motivates you to escape or avoid the situation, right? So this is adaptive because it increases the distance between you and the potential threat, right? So after freezing, when you see the bear, you may turn around and run away. And as far as avoidance goes, you may avoid that part of the forest in the future. A third thing that fear makes you do is what Marx calls aggressive defense. Right? Sometimes if you can't get out of the situation, fear motivates us to attack or threaten the predator. I know once when I was kayaking in British Columbia, A seal popped its head about 2 feet away from me, and then the beast lunged at my face or toward my face, and I had to hit him with a paddle to make sure they didn't bite me. So that would be an example of aggressive defense. The fourth thing that fear makes you do is submission or appeasement, right? So this involves adopting a posture of submission, which helps to indicate that you don't pose a threat. Now this usually works within a species, right? So many species where the males compete with each other, for example, for access to the females, after doing some competitions and maybe fighting for a bit, the weaker individual will adopt a posture of submission, and the more dominant male will then leave him alone. This won't always work when you're talking about a different species, of course, right? So you have to be careful. So altogether, when you look at these fear responses, you can see why it would make sense to talk about fear as an adaptation. Now, are certain fears innate? Right, that's the next question. So are humans and other animals more likely to develop some fears over others? So what we're talking about here is what's called the preparedness theory of fears. And this theory says that humans and other animals have a phylogenetically based predisposition to rapidly acquire fears of certain objects or situations. And these objects or situations are things that would have been a danger to our early ancestors. Right, so some terminology here, phylogeny is often distinguished from ontogeny. Right? Phylogeny has to do with the development or evolution of the species. Ontogeny has to do with the development of the individual. Right, so the idea behind the preparedness theory of fears is that our ancestors faced certain dangers, like snakes and spiders, so that during our ontogeny, right, during our development, or even once we're done developing and we're mature adults, we still have the tendency to acquire those fears. Right, so even if you hadn't been afraid of snakes before, for example, you can very quickly learn to fear snakes. So I'm going to start by talking about the preparedness theory and evidence for it, but I'm going to start with a discussion of a study on animals, right, since it's one of my favorite experiments. This is a study by Cook and Meinecke. They examined fear acquisition through observational learning in rhesus macaques, right, rhesus monkeys. So rhesus macaques are used as subjects in many animal learning experiments. And the question that they're addressing in this study is, do they have a preparedness to acquire certain fears by observational learning? Or is the equipotentiality assumption true of their fear acquisition? Now, two things I want to point out here. One is, well, they're looking at observational learning. And this is because many monkeys are very social. And just like humans, many of the fears that they acquire may be acquired by watching other individuals respond with fear. So you may learn to fear spiders, for example, by watching your dad respond with fear when he sees a spider. And the same may hold for monkeys. Right? The other point here is preparedness theory contrasts with the equipotentiality assumption. Right? These are the two opposites. The equipotentiality assumption is the idea that there are no biases in learning, that animals are equipotential learners. They can acquire anything with equal ease. There are no biases in their learning. So if you're talking about associations, for example, learning to associate one stimulus with another, all stimuli can be associated with equal ease, and it doesn't matter what those are. So that an animal would be able to learn to associate the light in a room with danger just as easily as the presence of a predator in that room being associated with danger. So in their first experiment, they asked whether rhesus monkeys can acquire a fear of snakes more readily than they can acquire a fear of flowers. And let me tell you a little bit about the task. This was done in a cage, and they had to reach over a plexiglass box. And across from this plexiglass box, there was a ledge, and on that ledge was a food reward. And the box was behind the screen that was open before each trial. Right, so each trial begins with the curtains closed, the screen opens, and they can see the food reward on the other side, plexiglass box in front of them. They got to reach over it to grab the food. Now the box had different stimuli inside. It either had toy flowers, realistic looking but toy snake, or wooden blocks, which was a neutral stimulus. And they measured fear on the part of the rhesus monkeys by looking at how much time it took them to reach over and grab the food. And they also looked at how many fear responses, how many fear behaviors they displayed within the trial. So fear behaviors are lip smacking, clutching the cage, screaming, or piloerection, right? Their hair standing on end. All right, so there was two groups in the study, right? Two groups of monkeys, the snake group and the flower group, SN plus and FL plus, they call them. So in the snake group, they observed the monkey do the task, exhibiting extreme fear to snakes and no fear to the wood blocks. Okay, so in the snake plus group, it's an observational learning experiment. So they watch films during the learning phase. They watch films of another monkey doing the task, and this monkey, they can see what's in the film. You can see what's inside the plexiglass box, and the monkey is either exhibiting fear when there's snakes and no fear when there's wooden blocks in the plexiglass box. The flower group, they also watch this monkey do the task, right? But the monkey that they see exhibits fear when there's flowers in the plexiglass box and no fear when there's wooden blocks, right? So the neutral condition is the same in both groups. Okay. So there's three phases to the study. There's the pre-test, the observational learning phase that's done over a 3-month period, and a post-test. In the first phase, the pre-test, the subject monkeys, right, do the task, right? They do the reaching task. They're put in a plexiglass. They're put in front of the plexiglass box, and there's either in the snake group there's either toy snake or wood blocks in there. And for the flower group, there's either flowers or wooden blocks. And then they record their responses, right? They look to see if there's any fear being displayed in the pretest, right? This is a baseline. So you would expect all the monkeys to be the same in the baseline because they haven't been exposed to anything different other than the stimulus that's in the box. And then, over a 3-month period, they watch this film of the other monkey responding in fear when there's certain stimuli in the plexiglass box. And then finally, there's a post-test where they look to see if a fear has been acquired during the observational learning phase. So here they do the reaching task again with the same stimuli in the box, and they look to see if there's been a change from the pre-test to the post-test. Now, you might wonder, well, how is it that they make these films, right? How is it that the monkey that they're watching manages to exhibit extreme fear to snakes, but not to wood blocks? And more interesting, how do they exhibit extreme fear when there's flowers in there and no fear to the wooden blocks? Well, the way that they did this is they manipulated the films. Okay, so the films that they started off with was with a naturally raised monkey doing the task when there was an actual live snake in the plexiglass box. And this monkey, because it had grown up in the wild, was fearful of snakes. So then what they did was, for the snake group, they replaced those shots of the actual snake in the box with the toy snake. And for the flower group, in the video that they watched, they replaced the shots of the live snake with wooden flowers. And they did this because they wanted to make sure that in each case where they're watching the film, the same fear response is being displayed by the monkey being watched. Alright, so let's look at the results from the first experiment. We have on the left how long it took them to reach over to grab the food. And we have the flower group and the snake group. And we have the data for the pre-test and the post-test. And what we can see for the flower group is that the length of time to reach over and grab the food, right, did not differ from the pre-test to the post-test. Right, so they didn't acquire a fear of flowers, right? Because when there's a toy flower in the plexiglass box, you don't see an increase in the latency from the pre-test to the post-test. But for the snake group, we do see an increase in latency in reaching time from the pre-test to the post-test, right? After watching this film where they see the model displaying extreme fear when there's a toy snake in the plexiglass box, the monkeys themselves came to acquire a fear of snakes. Okay. And now turning to the number of fear responses, fear behaviors, again we can see that there's no increase from pre-test to post-test for the flower group, but for the snake group, there is an increase in fear responses, like the lip smacking, cage clutching, and so on, from the pre-test to the post-test. So what this shows is that they've acquired a fear of snakes, but they have not acquired a fear of flowers through observational learning. Alright, so what can we conclude from this? That the equipotentiality assumption is wrong. Right? Some fears are acquired more easily. Right? They acquired a fear of snakes more easily than they acquired a fear of flowers. But what they argue is that this doesn't show us, or this doesn't tell us how specific the fears are. Right? So we know that they're more likely to acquire some fears than others, but how specific is that tendency? Right? Do they acquire fears of all animals equally easily? Right? Or do we learn to fear certain animals? Do they learn to fear some animals more readily than others? Right? So are fears of animals acquired more readily than non-animals? Or is there a preparedness that's limited to dangerous animals? Right? So how specific is the preparedness? And this is the question addressed by the second experiment. So here, they didn't manipulate snakes versus flowers. They manipulated the type of animal, right? Either crocodiles or rabbits. Right, so do rhesus monkeys acquire a fear of crocodiles faster than a fear of rabbits? So again, they had a pre-test and a post-test, and there's an observational learning phase in between. And the items that they used was a toy rabbit, toy crocodile, and the wooden blocks. And they had so when they're doing the reaching task, they had all three different types of objects at different points in time, each group. But they differed, the two groups differed in their observational learning condition. So we have the R plus C minus group and the C plus R minus group. So that's rabbit and crocodile. R for rabbit, C for crocodile. In the R plus C minus group, the monkey that they're observing does the task exhibiting extreme fear when the rabbit is present but not when the crocodile is present. And the other group see a monkey doing the task but exhibiting extreme fear when there's a crocodile, a toy crocodile that's realistic looking, but not exhibiting fear when there's a toy rabbit in the box. And so let's look at the data. Again, on the left we have the reaching time, right, from pre-test to post-test. So we have on the left R plus C minus, right, and what we can see then is that the leftmost bars are the latencies for the toy when the toy crocodile is present. The dashed lines in the middle are when there's a toy rabbit, and the blackened bars are when there's the wood blocks in the plexiglass box. Okay, so what we can see in the R plus C minus group is that there is no increase in latency from the pre-test to the post-test for the reaching time when there's a toy rabbit present, right? Even though they watched the monkey respond with fear when there was a toy rabbit in the plexiglass box. But if we move to the right, the C plus R minus, we can see that there is an increase in reaching time between pre-test and post-test for the crocodile stimulus, right? When they watched the monkey respond with fear to the crocodile, when a toy crocodile was put in the plexiglass box, in the post-test, they did increase the latency with which they reached over to grab the food. Okay, so the way to summarize this is to say that they were able to acquire a fear of crocodiles, but they were not able to acquire a fear of rabbits. And we see the same with the fear responses, right? When they don't see, on the left, when they don't see the model respond with fear to the crocodile, their latency actually decreased from the post-test from the pre-test to the post-test. And when they responded with fear to the rabbit, right, the middle bars there, we don't see an increase in fear response from the pre-test to the post-test. But now, what about the C plus R minus group? Here we can see an increase in fear responses between the pre-test and the post-test for the toy crocodile stimulus. Right, so again, they seem to have acquired a fear of crocodiles, but they did not acquire a fear of rabbits. Right, so what this tells us is that there's a preparedness in rhesus monkeys, not to acquire fears of animals, right, but to acquire fear of animals that are potentially dangerous. Right, so an interesting research question would be, well, what distinguishes in the mind of the rhesus monkey between a dangerous animal and a non-dangerous animal? Right? Probably something having to do with the shape, which is all they could go on in the present study. All right, so to put this part of the lecture together, right, the preparedness theory of fear acquisition is true, and the equipotentiality assumption is wrong, at least for rhesus monkeys. Now let's turn to a preparedness theory of fear in humans. Right, so Ullman and Meinecke have turned their attention to human beings, and they argue that humans also display preparedness to acquire certain fears. Although they can learn to fear lots of things, some fears are learned more easily. Right, so they say that we actually have a fear module, a specialized mechanism for fear acquisition. So they say a fear module is proposed to be a relatively independent behavioral, mental, and neural system that's specifically tailored to help solve adaptive problems prompted by life-threatening situations in the ecology of our distant ancestors. Right, so the idea is that we have an information processing adaptation that helps us to survive by prompting us to avoid dangerous objects and situations. And they say that this fear module, this specialized mechanism, actually has 4 properties that make it modular. Right, the first is selectivity with respect to input. Right, so rather than accepting any input, as the equipotentiality theory would say, right, they argue that the fear module is particularly sensitive to stimuli and situations that are correlated with threatening encounters in the evolutionary past. Right, so things that would have been dangerous in our evolutionary environment help to trigger this module into operation. That's the very idea of preparedness. Right, so they say that we learn some fears more readily than others, and that we can look at the evolutionary environment to see what kinds of things we should learn to fear very quickly. So fear of heights, for example, would be a good example of this. You wonder, well, why are some people some people have a phobia. Most people have a fear of heights. Some people also have a phobia of heights, which is when it's taken to an extreme. But why should a fear of heights be so widespread? Well, we're terrestrial omnivores, right? We're designed to live on the ground. Even chimpanzees spend a lot of their time on the ground, and although they do spend some time on the trees, most of their injuries happen from falling out of trees, right? So it makes sense for us to also want to avoid high places because we can fall and hurt ourselves. So this fear keeps us on the ground where we belong. So what evidence is there that people acquire certain fears more readily than others? Well, there's lots of studies done. For example, one study done with inner city children in Chicago. They were asked to write down the things that they feared the most. What are you most afraid of? And what do they list? Spiders, snakes, tigers, and bears. Things that they would rarely encounter in the south side of Chicago, right? What they didn't list were things like guns, cars, electrical outlets, cigarettes, drugs, right? Things that are way more likely to kill them, right? Didn't even figure in their estimation, right? They focus on things that would have been a danger in the evolutionary environment, but that they have almost no contact with in their daily lives. And David Buss also talks about this, right? Why do people go to psychiatrists? What are the main reasons they go? Many phobias that people seek help for are things that include like a fear of snakes and spiders, as opposed to a phobia for cars, guns, electric sockets, or even cigarettes, right? So they go to psychiatrists for fears that are less likely to actually be encountered in the environment. So they argue that this suggests that we have a fear module, right? A domain-specific tendency to acquire certain fears. And even though things like electric outlets, cigarettes, and other modern inventions are very dangerous, right, and can be very likely to hurt us in many situations, they say that they haven't been around long enough for us to acquire a preparedness to fear them. But really, we should, right? Whenever you see a cigarette, for example, you should run like hell because the damn thing's dangerous. Now, the other thing they say about the fear module, the separate fear mechanism, is that it functions with automaticity. Right? The response, the fear response can be triggered whether you want it to be or not. And why should that be the case? Because automaticity helps to make the system fast. Right? You want it to be triggered quickly, and you don't want to have to think about it too much because you want a fast response. Whenever the relevant stimulus is there, you want a fear reaction because it helps to keep you safe. Now, interestingly, people don't even have to be consciously aware of the stimuli in order for the fear response to be triggered, right? So fears can be triggered unconsciously. And another one of my favorite studies is by Ullman and Soares. They presented people with pictures of stimuli, one stimulus at a time, and they had to identify what the pictures are of. And they did the task, right? So they see a picture and they have to say what it is. And they did the task either under masked or unmasked conditions. In unmasked conditions, they just see the picture, it's up on the screen, and they can say what it is. In masked conditions, they see the picture very, very briefly, like it's flashed on the screen and very quickly replaced by another visual display, like a botched up picture, right? A completely rearranged and mangled picture that's unidentifiable. Okay, so that's masked. The stimulus is flashed for 30 milliseconds and then quickly replaced by something else. And under this condition, people cannot reliably tell you what that original picture is of. Right? So if you show the picture of a dog for 30 milliseconds and then replace it with a random pattern, people can't tell you that that was a picture of a dog. So they lack conscious awareness. Now, what they did was they measured the unconscious processing using the skin conductance response. Right? So they put a sensor on the fingertip, and this records how much the skin is sweating, which is a sign of stress. And the pictures that they used were pictures of snakes, spiders, flowers, and mushrooms. Now, the participants that they used in the study either had a phobia of snakes, but not spiders, or they were spider phobics, but didn't have a snake phobia. Right? And they also had a control group that didn't have either of these phobias. All right, so just to summarize here, they measured the skin conductance response of all the participants, and they did so under masked and unmasked conditions. And let's start here. These are the results. Let's start on the right-hand side, the non-masked conditions. We have the three groups of people, right? Those that were fearful of snakes, fearful of spiders, and the control group. And we have the 4 bars per section for each of the 4 types of pictures. And we can see the skin conductance response for the snake people. They had the greater skin conductance response when we were looking at pictures of snakes. The spider people, right, those with spider phobias, had the greatest stress when they were seeing pictures of spiders. And the control group didn't show any increase for either of these stimuli. None of that's surprising. They have this phobia, they're consciously aware of this picture, and they exhibit stress. What's interesting is what happened under masked conditions, when people can't reliably tell you what the picture is of. Here we see an even more, for the snake people, right? We see an even stronger stress response when they see pictures of snakes, even though they don't know that that's what they're seeing. And the spider phobes, they had a strong skin conductance response when seeing pictures of spiders that they can't reliably tell are there. Okay, so under non-masked conditions, the snake-fearful people showed increased SCR as a result of seeing the pictures of snakes. The spider phobes showed increased SCR to the photos of spiders. Right? But under masked conditions, which is what's interesting, we see at least as much of an SCR among the fearful groups. All right, so that shows the automaticity of the fear response and that you don't even have to be consciously aware of it. The third feature that they attribute to the fear module is what they call encapsulation. Right? So once fear is triggered, it's very resistant to cognitive influences. It's hard to talk yourself out of it. Right? The module works on its own, independently from other processes. Right? And the reason why this happens is because under conditions of fear, control over our actions is taken away from the cerebral cortex, the outermost layer of the brain, and control, the locus of control shifts to subcortical regions. Right? So they say when in danger, we're designed for relying on the evolutionary wisdom distilled in the fear module rather than for trusting on our own thinking. Right? So, for example, when you all of a sudden see that there's a spider on your arm and you freak out, you quickly hit it away. You didn't have to think about that. Right? In fact, you probably started responding before you were even aware fully that that's what was on your arm. And finally, specialized neural circuitry. Right? There are specialized parts of the brain that are involved in processing fear, and the part that's most closely associated with fear is the amygdala, right? Part of the limbic system. And so let me talk a little bit about the hardware here. Input from the eyes gets sent to the thalamus, which is a relay station for sensory information. And from the thalamus, there's a direct route to the amygdala, right? And from the amygdala, that causes the fear response, right? That's called the short path to the fear response. But there's also a long path, and that goes from the thalamus to the occipital lobe in the back of the brain, where conscious visual processing happens, and from there, there's pathways to the amygdala. Right, so we can see those here. So we have this guy walking through the deserts, and he spots a snake, right, a rattlesnake. You can see he's looking at the snake. The visual information gets sent from his eyes to the thalamus, and from the thalamus, the image of the snake is sent to the amygdala, and then a fear response is triggered. And he can actually start running or carrying out some evasive action or freezing before he's even consciously aware of the stimulus. Right? Before the thalamus even sends the information to the visual cortex. All right, so to summarize, people seem to have a fear module that functions independently of other processes, and it allows for prepared fear responses to things that would have been threatening in the evolutionary environment. Now, obviously, people can acquire other fears, right? But these other fears take a lot more time to learn, a lot more conditioning. For these prepared theories, they can be acquired with minimal exposure. All right, thank you very much.